Hello, and welcome to our ELECOMP Fall 2023 Winter Symposium. We are Team RDSI, and the purpose of this presentation is to inform you about our project, the Critical Data Relay, which is an aggregation of data from first responders to a Windows API display. To begin, I would like to introduce our esteemed technical directors. In order of appearance from left to right, we have Jamie Gagnon, our consulting technical director, responsible for providing us with the technical background help that has made this project possible. Next, I would like to introduce Hannah Mercy, a recent graduate from this ELECOMP Capstone program, now working for RDSI as an electrical engineer. And finally, I would like to introduce Bruce Torman, mechanical engineer and engineering manager at RDSI. Now, let's meet the team. Team RDSI is composed of two team members, Juan Cante, studying computer engineering, and myself, Eric Slater, also studying computer engineering. Before we dive into the project, we would like to take a moment to also provide an overview of the sponsor company, RDSI, which stands for Research and Development Solutions Incorporated, headquartered in Pawcatuck, Connecticut. RDSI is a service-disabled veteran-owned small business that performs a wide range of engineering, technical, and programmatic functions in support of various government and commercial clients, and specializes in delivering affordable, scaled, state-of-the-art solutions to the government and industry clientele. RDSI Department of Defense portfolio includes expertise in the areas of submarine imaging, electronic warfare, and weapons, to name a few. In support of public safety projects and clientele, RDSI has strong connections with local public safety efforts such as the Rhode Island Office of the State Marshal. The motivation behind this project is to modernize the current firefighter experience when it comes to referencing hazard response information for chemical spills. The Emergency Response Guidebook, where this information is available, is comprised of three main sections: a yellow and blue section for indexing chemicals either by name or by chemical ID number, orange pages which contains chemical hazard response information including potential hazards, public safety guidance, and emergency response instructions, and finally, the green pages, which contains evacuation range tables for certain chemical spills. The current process for firefighters involves searching through the yellow and blue pages of the book to identify the chemical, finding the correlating guide page in the orange section, and potentially referencing several tables for evacuation distances, and the green pages depending on the chemical. Our predecessor team, 2022-2023 ELECOMP Team RDSI, developed a prototype proof-of-concept phone application for accessing information in the Emergency Response Guidebook on mobile devices. Now RDSI would like to develop a package and produce a full first responder technical solution on a Windows device. Now that we've established a foundation for our project, I will explain the solution our project will produce. As RDSI plans on creating a packaged ruggedized laptop loaded with RDSI software for accessing emergency response information, we will be creating the first stage of this product. Our anticipated best outcome will be a software application which RDSI can combine with their own sourced laptops to sell to first responders. This tool will initially be loaded with a digitalized version of the Emergency Response Guidebook with room for RDSI to add and develop other tools to market their product to the other first responders in the future. Our team's key technical accomplishments thus far are the desktop application created in Windows Presentation Foundation, WPF, and an accompanying SQLite database containing data from the Emergency Response Guidebook. Using WPF, chosen as a software application platform as its purpose-built for Windows desktop applications, we migrated the layout and technical accomplishment of the previous team to a Windows solution and updated the UI for use in a desktop environment. For back-end development, we created a database using SQLite, which is a lightweight version of SQL standing for Structured Query Language and is a programming language for storing and processing information in a relational database. This database was created from our team from the ground up, including defining the database schema design and seeding the data with information from the Emergency Response Guidebook. Now, before we delve into the technical details, let's discuss the economic impact of this project. For RDSI, a successful achievement of the anticipated best outcome and its planned release after further development by RDSI would result in improved relations with first responders, establishing RDSI as a tech leader for first responder solutions and innovations, fostering a strong relationship in the future between the company and local departments, as RDSI opens up the market to more technological products to improve first responders' safety and capabilities. Here is a simplified block diagram illustrating the flow of activity for our project. As shown, the application first guides the user to determine and identify the chemical while the application queries the database for the information. Next, the information is accessed from the database, is displayed to the user, and the user can then decide to query new materials. For my individual technical accomplishments, I have been responsible for back-end development of the application and ensuring the functionality of the SQLite database. Thus far, I have designed and implemented within the SQLite schema entities for the chemical and guide information. Entities are individual objects within the database which can be accessed and processed and individually defined reference data for a chemical or response information for a guide page from the Emergency Response Guidebook. The next step to this process was filling the database with an initial set of information, otherwise known as data seeding. In order to create the entities used in the database, we use the datasheets for the Emergency Response Guidebook made publicly available by the Department of Transportation, and converted the data into files I could access and read with a program. The data stream from the files were then tokenized and used to populate entries in the database, which can then be used by the application in query and display information. Between now and the completion of the project in the spring of next year, I plan on completing the SQLite schema design with entries for the evacuation distance tables located in the green pages, which consists of 3 tables of context-dependent data values based on factors such as the chemical, the size of the spill, and the time of day. Once the database is fully functional and seeded, the next stage will be camera integration for the application so that first responders may access chemical hazard data without manual data entry, as text recognition working in tandem with the visual data feed will read chemical plaques such as the example shown here for flammable paints and paint materials and promptly display the needed hazard response information. At this point, I would like to introduce my partner for this project, Juan Cante, a fellow computer engineering major who has been as equally committed as I have to achieving our anticipated best outcome for the project. I'll now hand it over to Juan, who will discuss his work with the front-end development of the project.
Thank you, Eric, for the introduction. The first task I decided to work on was the main menu for the graphical user interface, or GUI for short. The main menu consists of the RDSI logo front and center. Then we have 3 buttons near the bottom of the screen. These buttons are used to navigate throughout the application. And once I completed the main menu, I worked on the input screens. These 2 screens would be where the user inputs either the chemical name or the placard ID. The next task was to replicate the warning screen from the previous prototype. This page starts off with warning the user to not use the app if multiple hazards are involved, and then it lists off all of the appropriate emergency response agency phone numbers. 1 number for Canada and 6 for the United States. I also added a button that in the future will contact the NRC. As you can see here, we have a screenshot of the main menu. We have the RDSI logo at the top and our 3 navigation buttons leading to the chemical name input page, placard ID input page, and the camera, which currently has no function. Here we have another screenshot. This is our placard ID input screen. As you can see, we have a back button and a label to indicate which page the user is on. Then we have a text box where the user will enter the placard ID number. Currently, the screens in the database is all we have completed so far. I plan on implementing the database so that the app can have full functionality with the database. With this in mind, I also have to design and develop the Windows page that displays the data. Once the page is finished, I have to add the standardized basic functionalities like back buttons or next buttons to move to the next piece of data. In the future, we plan on finishing the database by adding the green pages. Then we plan on updating the user interface to RDSI standards. And we also plan on integrating the camera feature to detect chemical plaques. Lastly, we would like to thank our technical directors Hannah and Bruce for their amazing support. We also want to thank Jamie for his assistance, and most importantly, we want to thank Dr. Sunak for the opportunities to gain real-world experiences. Thank you.